Hi everyone. Dimitri, can you please verify that we are live and you can all see and hear me? Dimitri? Okay, great. Thank you very much. So, welcome again, everyone. This is the 12th and last session of our Introduction to Digital Currencies MOOC. I'm Giaglis. We've reached the end of the road. Thank you for your patience and your persistence for being here. After 6 weeks with Andreas Antonopoulos, 3 weeks with Antonis Polemitis, and 3 weeks with me, this is the end of this course. So we're going to do two things today. One is we are going to discuss how blockchain is converging and is expected to further converge with other technologies, namely artificial intelligence and the Internet of Things. And we are also going to present a quick preview of how our master's degree in blockchain and digital currency is changing towards the end of this session. So as we did the previous 2 weeks, I'm going to do two things. One is I'm going to start by going quickly through the slides. So I'm going to assume that you have all read the slides. So I'm going to focus on the most important points. And when I finish doing that, I'm going to go through your questions. First of all, I would like to thank you very much for the questions that you posted on Moodle this time. They were really, really very interesting. And as always, please feel free as I'm going through the slides and then during our discussion to also post additional questions on our chat. So we're going to start by a quick preview or overview of the two technologies that are not technically part of this course. This course is about digital currencies and blockchain, but since we're talking about convergence with other technologies, we might as well spend a few minutes describing what these technologies are for those of you that may not be so familiar with them. So starting with the Internet of Things, as the name suggests, is the Internet as we know it, so a fully distributed global TCP/IP based architecture. But in this case, it is not humans that are being connected to it, it is machines. It is everyday objects. It is literally everything. Now, you will tell me that technically, even in the internet that we are using, the internet of humans, it is machines that are being connected to it. It is our computers. So the difference here is that we are talking about machines that can be very, very small, even to the extent that they are invisible to our eye. They are equipped with sensors, so they are machines that are able to measure things around their environment. So maybe their temperature, the humidity, the speed in which a car is traveling, or any other environmental signal. They have embedded software that allows them, I mean the machines themselves, the objects themselves, to process this information they receive from their sensors, and being connected to the internet, they are able to communicate with other devices and pass this information on. So there's no human involved, there's no computer user that is using the machine. The machine is operating by itself and through a pre-programmed logic that is running within the device itself. Now, those that have not heard the term before, they tend to find it an interesting one, but they consider it to be somewhat peripheral. And they do not grasp that the Internet of Things is already here and is already, since many years, much larger than the Internet of Humans, the Internet as we know it. We estimate to have around 50 billion devices connected to the Internet of Things already, anything from thermostats to in our house to connected airplanes that fly in the sky. And this makes the Internet of Things the first technology in the history of humanity in which machines outnumber people by an order of magnitude. So there are 7 billion of us in the planet. We already have more than 50 billion devices connected, and there has not been any technology since now in which machines were more than us, with any implications that this might have. I've tried to summarize here, although it's very difficult to do in one slide, the types of applications that the Internet of Things has or will have. So we're talking about both consumer applications. So for example, smart home, the wearable smartwatches that we wear on top of us, health applications and so on, but also enterprise applications. One of my favorite areas of application of the Internet of Things is in transportation, where we have what we call there in the slide vehicle to everything. So this is what V2X means, vehicle to everything communications. So we have vehicle to vehicle, vehicle to infrastructure, vehicle to passenger or driver. So there's an ongoing development of applications that will enable the end vision of moving to autonomous driving, where our car will not only be able to drive itself on the road by being able to perceive what's happening around it and behave accordingly, but also be connected to other cars and the road infrastructure itself, so that the cars themselves form a group, a team that self-organizes on how they're going to be managing their behavior on the road. So we're talking about really innovative applications that are going to disrupt the way we live in the next few years. Obviously, as with every new technology, there are a number of issues and challenges associated with IoT. Again, I tried to summarize them in one slide, although there's lots of things that we can say about them, starting from security and respecting our privacy. We have devices that may be invisible to us. There could be computing functionality in everyday objects that we do not perceive as having such functionality. Or even if we do see them, we tend to forget about them. So if you've got, I don't know, Alexa at home, you tend to forget that this is a device that actually listens to all your conversations. So, okay, now from listening to them to actually doing something with them, understanding them, sharing them with others or whatever, there's a long road. But once you start having this surveillance type of equipment around you, they can give rise to a number of applications that you would like to have, but they can also be compromised, hacked, or misused and expose you to things that you wouldn't normally want to be exposed. What makes things worse in the case of the Internet of Things is that we are talking about devices that are usually pretty small, have very limited computing power and memory of their own. So as opposed to the computers that we are using, we cannot update their software, we cannot really use sophisticated encryption algorithms for whatever they store or they communicate. So they have been designed for less, let's say, sensitive applications. But as we're moving to more sophisticated and more sensitive applications, this becomes a big issue. I was reading only this morning an article about a group of hackers that claimed, it's not a proven claim, that they were able to hack into a Tesla car remotely in a matter of minutes. So if you're driving a car tomorrow and someone from a distance can take control of your car as it drives through the road without you being able to do anything while the car is on the move and with you inside it, I mean, I don't need to say much. You understand that we're talking about a totally different state of affairs. So everything from enterprise security to future cyber wars, there are issues that we need to resolve when it comes to IoT. And also we need to resolve the challenge of big data, because if we have literally tens of billions of devices with sensor capabilities, monitoring signals of their environment 24/7. We're talking about zillions of data points that create unprecedented volumes of data. So on the one hand, that's a good thing because we can do things with this data. On the other hand, we need to figure out how we're going to sift through all those data and find what is important and what can be acted upon. A few quick words about AI as well. AI is a difficult thing to define, so I like the definition in the second bullet there, that we call artificial intelligence whatever hasn't been done by computers yet. So the goals are shifting when we're talking about AI, because there have been things that machines weren't normally able to do. So 20 years ago, a machine that was playing chess was definitely in the realm of AI. Nowadays, you can, buy on the commercial market software that plays chess much better than the world's best human chess player. So this is not considered AI anymore, it's considered everyday computing. So every time we solve a challenge, this moves from being an AI problem to an everyday computing thing. And nowadays, AI is about robotics or autonomous vehicle, as we said, or natural language processing or things like that. In a few years' time, maybe these are going to be challenges that are going to be solved. So we're going to consider it pretty normal that we converse with a machine the same way we converse with a human being. And then AI would be considered something which would be, at the state of the art challenge then. AI has been around since the 60s, so in reality it's not a new technology, but it has taken a whole new momentum in the last few years because of deep neural networks, because of developments in research that allowed us to make really substantial leaps in what AI programs are able to do. And nowadays we have computers that are much better than humans in a number of tasks that were not considered solvable by computers only a few short years ago. There are a number of versions of AI. We are now in a stage that we could call artificial narrow intelligence. Narrow in the sense that machines can now do a narrow set of tasks. So we used to have machines that were programmed to do such stuff by equipping them with rules, sophisticated strategies, lots of examples and stuff like that, like the early chess machines. We now have moved to something that is called machine learning. So machines can learn on the fly to do a specific set of tasks, and they become better the more data they have. So the more experience they gain by doing a specific task, the better they become. But it's still narrow intelligence in the sense that once a machine learns to do something, for example, recognize, faces in photographs, it becomes progressively better up to a point in which, it's much better than the world's best human in recognizing things in pictures, but it cannot do anything else. So it's the world's best picture recognizer, but they wouldn't be able to make you a coffee or do your shoelaces. So that's what narrow means. The challenge now is to move to something that we call artificial general intelligence, in which machines will really possess human-like abilities, because we are able to learn like machines do, but not on a specific subset. I can learn about blockchain, and the next thing I can learn to play guitar. I've learned to speak Greek or English now. I can move to different domains and start learning without being reprogrammed or reborn or whatever as a human. So once we get to the stage where we have machines that will be able to use this human-only ability now, or living organisms only ability to keep on learning by experience and develop their intelligence, then we will enter the realm of artificial general intelligence. And then the final frontier, which is only science fiction at this point in time, but there are scientists that are saying that this might be reality sooner rather than later, is a state that we call artificial superintelligence that we discussed a little bit last week when we said that at some point machines will outsmart humans. This is the famous or infamous, depending on where you stand, singularity moment where machines outsmart humans, become more intelligent than us as a species, and nobody knows what's going to happen after that. And I have some of your questions on that we will tackle later. AI has been obviously a huge thing lately. There's literally hundreds of companies all over the world working on AI. There's a huge geopolitical even race between mostly the US and China on who's going to dominate the AI world, and all the tech giants are, in a shopping spree, acquiring AI companies and building AI capabilities into their arsenal. So, with this background on IoT and AI, let's spend a few minutes also discussing how blockchain, how distributed ledgers, how smart contracts, and how digital currencies are probably going to converge with these technologies, and see what's going to happen when this happens. Now, the interesting thing about IoT and AI is that, like almost everything in the internet world, they are exponential technologies as well. So if you see the way that IoT sensors have grown in the last few years, this is a classic exponential curve. Computing has gone through an exponential curve based on Moore's law, and we have seen the early slow stages of an exponential curve, and we're now moving to the much faster growth rate of these technologies. And since blockchain and the networks built around digital currencies are also exponential technologies, it is a very, very interesting mix what is happening when not only one, but two or three such technologies come together. So if we agree that individually each of these technologies deserves the attention they are getting as enablers and disruptors in our worlds, what's going to happen when they are taken together? When we start having applications that are going to be using all three of these technologies? I think what's going to happen is that the transformative effect of these technologies will become multiplicative, and since they are exponential, they're going to release a period of unfathomable rate of growth and accelerating growth in what we are able to do with technology. And I think the future, our future, is going to be driven by this machine connectivity, because you have an underlying infrastructure of the Internet of Things that connects billions of devices and generates unprecedented quantities of real-time streaming data about the way the world operates. Effectively, we're creating a mirror of our physical world on the internet, a digital representation, digital matrix, if you'd like, of everything that's happening in the world. And then the more our software becomes intelligent and we have AI, these machines are going to be able to make sense of what this data they gather from their surrounding environment mean. Then they will be able to act upon this data and trigger services. And this is, I think, where blockchain comes into play, because these machines will need to do a sort of handshake and be able to agree with each other on things that are happening or on services that they're going to be assigning to each other. And you need this storage layer where everything is going to be secure, and you need this transaction layer where contracts need to be self-executable and self-enforceable, and you need to have this payment layer where machines will pay each other for services they assign to each other. And this is where blockchain comes into play, because it provides both the storage, the transaction, and the payment layer. So apart from smart contracts, which, as I said, are going to be the contractual layer of such economy, digital currencies are also interesting in the sense that they're creating new forms of money, money that is programmable, so we can write code on our money, attach this code to the money itself, and active. So our money will be able to determine for themselves what they are going to do, not wait for an explicit command by a human user on where to be invested or moved to or whatever. And if you have such money, programmable and active money, then we can start thinking of a machine economy, an economy in which the owners of that money for the first time are not going to be only humans. We used to joke with eccentric people that were dying and were leaving money to their dogs as inheritance. But now, for the first time, we can conceive of the notion of machines or even software code owning its own money. And once this becomes possible, it opens a whole new door of possibilities, equivalent to the door that was opened when we first conceived of the notion of the corporation. So when we conceived that, apart from us as humans, we can have these abstract legal entities, our companies, that would have a legal presence. They could take you to court or be taken to court, and they could hold their own money. But even in that case, these abstract entities were operated by humans. Now we're thinking about other abstract entities, or rather not non-abstract, that will be autonomously operating. So we're talking about a totally different economy that might be difficult for us to even keep up with. So I think the convergence scenario will play out something like this. We have an underlying infrastructure of the Internet of Things in which sensors will allow us to cost effectively gather huge amounts of data. These devices are going to be connected on the internet, so this data will be able to be transmitted either on a peer-to-peer basis between pairs of such devices or broadcasted across a network. And what is missing from IoT is intelligence. So how we're going to act upon this data. And this is, I think, where AI comes into play, because AI today is rather cumbersome and rather it requires huge computing power that cannot run on IoT devices. The artificial intelligence of today is very centralized, but in the future it will become decentralized. It will go to the edges of the network and it will create mini brains on the IoT devices. And this will allow these devices to not only sense what's happening around them, but also recognize meaningful patterns of things that are happening around them in ways that most humans will not be able to do ever. And then, when you have machines able to sense their environment and able to make sense of what they perceive in their environment, what is missing, as I said, is a commercial layer, a layer that would allow you to securely store this information, generate, initiate, trigger transactions, and pay each other. And I think this is where blockchain comes in, or decentralized ledgers come in, because they would allow machines to form networks that have all the benefits of decentralization that we discussed the previous weeks. So no single point of failure, disintermediated structures, unalterable records, self-enforcing contracts, and tokenized instruments in which they can pay each other for services. So this is what I think the technology stack of the future will be. And at the end of the day, what this will enable is machine-to-machine commerce. So I think we have, on the one hand, we have crypto that creates new forms of money that might be ideal money for machines that will not be able to transact in euros or dollars. On the other hand, we have the Internet of Trust, as we discussed, that is being created by blockchain, and together with AI and IoT, I think it might remove middlemen in the sense of removing everyone. And the consequences would be that we would have autonomous AI-based economic agents that will unleash a period of human-to-machine or machine-to-machine commerce. And we've discussed a number of that stuff, so I'm not going to go through them again. We will need to have identities for these machines. We will need to have identities for objects connected on the Internet of Things, and this is where self-sovereign identities enabled by blockchain can become important, and we can build decentralized organizations autonomously governed by the code that forms the entirety of their existence. Of course, as I said, there are challenges here. We will need new system architectures to build such applications that are native to these technologies, and we will need to solve a number of problems. I mean, it's been 10 years that we have blockchain, and we still haven't, by and large, solved the problem of interoperability between blockchains, let alone interoperability with AI and IoT. We will need to build advanced analytics capabilities. Data science is nowhere near the level of sophistication needed to support such a world. And we will obviously need new business models, as we explained last week, because it's not going to be only about disintermediating the current players, but creating wholly new players and wholly disruptive business models for this economy. So these are not things that we will see in the coming, let's say, 5 years. This being the last lecture, I think it's a good opportunity to open up our imagination to things that might happen 10 or 20 years from now. So, concluding, and you will allow me to sort of read this slide because I think it contains the key takeaways from this session of the course. On the one hand, we have three technologies, the Internet of Things, AI, and blockchain, that are foundational infrastructure technologies that are growing exponentially. And I think when they combine, they will create a new Internet of connected through IoT, intelligent through AI, and commercially transacting through blockchain machines. And this will unleash a new era of machine-to-machine, human-to-machine commerce. This era will have profound consequences on our social and economic dynamics, and at some point I predict or I expect new forms of organizations that are going to have no humans in them. They're going to be existing only from code, and connected machines will emerge. But as I said, there are challenges that must be overcome first, and challenges in all three of these technologies. So in the Internet of Things, it is a big network. It has outgrown the human internet, but is still a largely passive, insecure, and privacy vulnerable network, as we said. So we need to solve security, privacy, and scalability issues related to IoT. AI, as I said, is still very computing intensive and centralized. We need to be able to allow machines with less computing capabilities to be intelligent. We are a few years away from that. And distributed ledgers, we've been discussing them throughout this course. It is a new technology. It's largely untested at scale, and things like smart contracts and tokens lack both the regulatory clarity that's required for mass adoption and the security and scalability and interoperability needed to have them proliferate across the economy. Okay, so this concludes the first part of the presentation. I think before moving to the preview of the MSc, it might be a good idea at this stage to look at your questions. So let me see, first of all, Okay, I see there are a number of questions in the chat, so if you allow me, I will start from those. Daniel asks if we can summarize the convergence as follows: IoT is the infrastructure, AI is the governance, blockchain is the consensus. Yep, that's a pretty accurate description of what I'm saying. Thank you very much for that. I might steal it from you and use it. Victoria is saying that perhaps IoT, AI, and blockchain will supplement existing digital and offline infrastructure governance and consensus. Yes, I'm not talking only about, wholly new applications. As we said, what happens in these cases is two things. First, we're taking existing applications and we're moving it to new technologies, and this is going to happen with AI, IoT, and blockchain. But then we're going to start building things that most of us, at least me certainly, cannot even imagine at this point. So there's going to be innovation it's like we were in the early years of the internet and you asked someone to imagine, I don't know, Instagram or Uber or Airbnb. It simply wouldn't be possible for most people. Um, I have another student saying that IoT is the infrastructure, AI is the processor, blockchain is consensus and security. Yes, security not in the sense of cyber security, security in the sense of trustless transaction between machines, because blockchain is not inherently more or less secure than other technologies. What allows you to do is to build trust or build this security without an intermediary. I have a comment that says that blockchain does part of the governance with smart contracts. I wanted to say that earlier, so thanks for pointing that out. Yes, in the previous scheme, the governance is being, let's say, shared between the AI and the blockchain layer, in the sense that AI is governing what is happening within the IoT device, and blockchain is governing what is happening on the transactional layer throughout the network. Is like the distinction between your private keys that you have and then the consensus mechanism that goes around in the network that says whoever possesses the private key to this address is actually the holder, the legitimate holder of the coins locked in this address. How do we explain the advantage of regulations for the blockchain technology adoption and the censor-resistant property of blockchain? That's a very good question. You know that one of the advantages of blockchain, I think my co-instructors have stressed that frequently, is that it is a censorship-resistant technology. So once someone participates in the network and they post a transaction or whatever, nobody can censor that transaction. You cannot block someone, cut them out of the network or whatever. And this is a huge benefit for inclusiveness and growth. However, this solves largely problems that have to do with individual exclusion. There are also problems that work at the institutional level and what happens at scale. We have regulations, forget blockchain for a moment, we have regulations for a reason. Believe me, you don't want to go back to a world where there's no rule of law and where whoever is stronger gets their way and the weaker are dead in the sand. You need regulation to be able to make progress and uh, to incorporate, let's say, safety and trust in our transactions. And regulation has enabled all these things. Now, we are now able to automate some of this. We are able to automate the execution of what we have agreed. But as you have seen in many cases, you cannot always trust code for making the right decisions, and maybe the code we create is even wrong, or even worse, it does what we wanted it to do, but we realize after all that this was not what we wanted it to do, and now we cannot change it because it's self-executable and censorship resistant. So in order for institutions to be part of what's happening in the new economy, you will need regulation. You need regulation to be able to have as the central banks are the lenders of last resort, you need to have a refuge of last resort when something goes wrong. That's why I believe that this expectation of total delegation of regulation and trust to machines is probably, at least for the foreseeable future, overinflated. Gregor is saying, will Uber then launch a fleet of self-managing driverless cars, or do you see new co-ops emerging to organize this? Again, that's a very good question, Gregory. Well, my personal prediction is even more, let's say, exotic than this. I don't think that it's going to be Uber or another Uber-like company that's going to dominate this world. You're probably thinking, or we are probably thinking in very today's terms. If we are true to what we believe about decentralization, then most probably what's going to happen is that the cars of the future are going to be autonomous organizations. So now you have a car, the car has an owner or driver, and you got Uber as a centralized company that has the platform that coordinates and synchronizes everything that is happening. Well, imagine in the future that each taxi that operates out there is a business of its own. It's not part of a fleet of cars that belonging to a company. There might be such companies, of course, but there will be independent players. Like you have now self-employed persons, they're going to be self-employed cars. So I will be, I might have my car, I use it to drive me to work, and in the 8 hours that I'm in the office, I unleash it, and it goes out and makes money for me. Not by synchronizing with a central provider of an infrastructure or a platform like Uber, but by actively seeking rides around it. So connecting to digital assistants of people, my mobile phone has access to my calendar. It knows where I need to go after I finish this class. So it's not inconceivable that, 30 minutes before the end of the class, it will publish a request to vehicles in the area saying that, George needs to be there by then. You need to pick him from here at 6 o'clock and he needs to be there by, I don't know, 6:30. And then my digital assistant will start receiving quotes from the vehicles that are in the area. The vehicles are going to be negotiating price with each other and with me, my digital assistant, purely based on software without having any, driver in them. And whoever wins my ride is going to be there. The money is going to leave my digital assistant's account and going to go in escrow. And when my mobile sees that its GPS signals tells it that it is at my destination, it automatically releases the escrow part, and this digital currency then moves from my account to the account of the vehicle that is operating. And this vehicle will be using this money to go and recharge itself or go and do a service when it needs to. And at the end of the day, it might turn a profit, and this profit will go to some human owner. But this is the world that I'm thinking. Joseph is asking, do you think some of the future applications that will come out as a result of the convergence will create a legislation and regulation challenges? Undoubtedly. I mean, there's no question about that. We live in a world in which these things are still untested. And that's always a dilemma, because you need innovation to test new ideas. Innovation works much faster than regulation. So in the beginning, in the absence of regulation, you will have all sorts of problems, and then regulation will need to pick up speed and get up to pace with what's happening. It's probably the parallel that most recently we've witnessed in the ICO boom. ICOs started with things like the Ethereum crowdfunding, which was fantastic, and then other companies picked up the innovation of being able to use digital currencies to do global crowdfunding campaigns, and suddenly the whole thing exploded, and lots of fraudsters and scammers entered it, and we all knew uh, where this resulted in. So again, we can connect this to the discussion about regulation and why it's needed. It's not always uh, to, to do it in new applications. Uh, Again, by Joseph, should legislators be first trained on the impact of this technology so they work to create laws that would help the progress of these applications? Yes and no. I mean, I work in a university, we do training, and we're training legislators. We do lots of professional training on aspects related to blockchain regulation. But you need to understand that these are very fast moving technologies, and legislation is moving at a much slower pace. So it's genuinely difficult, if not impossible, for regulation to be at the same level as technological development. And it probably doesn't need to, because then you're chasing uh, what is happening in technology, and not all technologies will create life-changing situations in our world. Gregory is saying, I understand the concept of the autonomous car, but who will take the initiative? It needs building and putting on the road. Well, I think I had an example between Uber and Hertz, and you might have heard that as of a few days ago, Tesla's market cap surpassed $500 billion, and Elon Musk is now the second richest person in the world. So when something shows promise, the answer is that smart money will follow it, and there's gonna be lots of initiatives and well-funded initiatives to make it a reality. If what I'm describing has not happened today, is because we are still too early. It's still not mature enough to see commercial exploitation. Why escrow account? Why not multi-sig scheme? Yeah, escrow account was just an example. It could be anything. So thank you for that. Let me go a little bit to the questions that were posted on Moodle. Okay, so Ray is asking, will artificial intelligence take over humanity? I don't know. There's been predictions ranging from a period of utopia, the age of Aquarius, where we will not need to do anything. Machines will be doing all the petty stuff. They will unleash a period of huge economic growth, and everyone in the world will reap the benefits of that growth. So we'll all be much better off. And there have been predictions that machines will rise up and enslave us. I don't subscribe to either of the two extremes. I think they are imagination grasping extremes, but what will probably happen is something in between. So as we have seen with all technologies up to now, technology tends to improve the well-being of everyone in the end. So everyone is much better off. The poorest people in the world today are much better than, even the kings and aristocrats of 100 years ago. So, regardless of whether you were the king of England, 100 years ago, if you were bitten by an animal and there were no antibiotics or whatever, you were dead. So conceivably, even an average person today is much better than the richest person of 100 years ago. But technology also tends to increase inequality. So the poorest person today does not compare themselves with the poorest person or the average person or the richest person 100 years ago. They compare themselves with the average of today, and they feel, and rightly so, that they have been robbed of opportunities or whatever. So, yeah, I don't think AI will I don't know, dominate or enslave or um, uh, bring down humanity, but I also don't think that all effects are going to be positive. There are going to be huge tectonic changes, and these changes usually generate large historic periods of frictions. Uh, Andrew is asking, do you foresee all flying cars and personal drones being RFID tracked on AI networks like old air traffic controls? Yep, this is pretty much, I mean, I'm not sure of whether it's going to be flying cars or unmanned flying vehicles like the drones, whether it's going to be RFID or NFC or some other wireless technology. I don't want to bet on the specific technologies. These tend to be invented all the time, but yeah, I foresee, as I said, a future in which vehicles connected on the Internet of Things, they're going to be operating either on the ground, on the sea, on tracks, or in the air, not coordinated through some air traffic control, but coordinating themselves in a mesh-like network that is self-organized. Dilver is asking, I would like to know your opinion about the cybersecurity issues that must be addressed in order to enable the relation between IoT and blockchain. I think I've covered it when I went through the slides. I think the issues have to do with the fact that these machines are inherently insecure. Uh, when you build a smart thermostat in your home or a smart, I don't know what, in your car, you don't build it to be the world's most sophisticated, double encryption, whatever standards. However, if this is taken over, then someone else has control of the temperature of my house or my car. And, in some situations, this creates a huge dilemma because you want these machines to be small, cheap, and abundant, and therefore not having so much security or privacy capabilities, but you want them to be very secure and very private. So this is a huge challenge that needs to be solved. Ludovic is asking, with all this new information we're learning and the possibility of singularity someday, how can we as students learn how to participate in this growth? For example, in a practical manner, how is one to know the future demand for the various cryptocurrencies? How do we determine the demand for Bitcoin, recently making the price get close to an all-time high of 20K, and so on? Well, obviously, there is a way to participate in all this. Go out and innovate. Build a company, start experimenting with these things. You're taking huge risks, of course. If you want to be a pioneer, you cannot do otherwise. You have a 99% chance of failure, but the 1% that will succeed will become, as I was saying last week, the world's biggest company. So whether it is cryptocurrency trading or it is building the flying drone autonomous swarm system of the future, obviously the horizon is open for innovators and inventors. James is asking, given the reason Elon Musk gave for developing Neuralink was to allow humans to tap into the power of AI and not get left behind when the artificial superintelligence takes off, wouldn't this only benefit the very few who have access to these closed AI systems? Wow, this is a very, 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 very good question. Thank you, James. Because it gives me the opportunity to say two things that I might have implied, but I haven't said explicitly. Thing number one of the likely scenarios of an era of artificial general intelligence is that AI is going to create what we call IA, intelligence augmentation. So machines are going to be smarter, but if we are able to plug our brains to these machines, then we become as smart as the machines because we have access to their intelligence. So in a future world where my brain is connected to Google, I don't need to ask you guys any question because any question my brain asks directly to Google and downloads the answer, so I know the answer to all the questions, at least the factual questions or the Google type of answers for everything. So one thing is that a plausible scenario of an AI world is that humans become as intelligent as the machines because they are somehow integrated with the machines. The second thing that I would like to say, and James puts it very nicely, is that I said earlier that technology tends to create inequality. And I frankly don't see any realistic way in which we can avoid even greater inequality in the future. Because this artificial superintelligence, if let's assume for the sake of argument that we do have it at some point in the future, it will not happen overnight. It will happen gradually. So some of us, companies for example, will develop it first. And when it's being developed first, it's going to be in the hands of a few. And if these few create an advantage against the others, they can use this advantage to remain ahead for, forever, maybe. So we might have a world in which, people and organizations are in different speeds. So I don't know, to give you an extreme example, imagine what's happening now with the COVID-19 vaccines. Once we have an effective vaccine, and we will have it sooner or later, it's not going to be immediately available to all 7 billion people in this planet. The president of the United States, if he becomes sick, as it did happen, will have access to therapies that the average Joe out there does not. And the same thing will happen, it's then philosophical and ethical considerations of whether this is a right thing or a wrong thing, or whether, the doctors and nurses should get access to the vaccine before the old people or whatever. I'm not taking a stance on on what's right. What I'm saying that it is unavoidable that not all people will have access to technological inventions as they happen. So yes, inequality will rise, and this will be, as James says, a threat to humanity because it will exacerbate the friction that already exists because of inequality in our world. Next question. When the artificial superintelligence stage is reached, it would appear that regulatory design and decision making could also fall prey or under the control of machine thinking. Are there innate and consequential risks within that need to be safely and irrevocably hard programmed with desirable outcomes into our collective future post the singularity? Oh, difficult question. As I said, I'm not a huge believer at this point in time in our ability to program regulation or decision making. Not because machines are not that intelligent, but because there does not exist in the human collective thinking an objective and agreeable upon everyone on this planet opinion about what constitutes a good regulation versus bad regulation. Some of us will prefer a more laissez-faire approach, others will prefer more, central planning or, capitalist versus socialist economic planning. And this is only economics. I'm not talking about social dynamics, anthropology, sociology, ethics, and stuff like that. So I think that many things are going to be programmed in machines. The non-machine law is going to be updated to recognize some of the legal elements that are going to be taking place in self-governed, algorithmically governed systems, but I cannot think at this point in time any universal, objectively agreed upon algorithmic governance happening. Final question by Ludovic, who's saying, George, can we have a little conversation about this? And he quotes something saying, US Treasury could destroy the true nature of blockchain by going after self-hosted cryptocurrency wallets. It seems that the US government is going after the backbone of blockchain now. What? I'm not sure that the US government or any government is able to go after blockchain. The technology is so widespread now that it has outgrown the ability of any government to do anything about it. I had seen or heard similar questions in the years of the early years of the internet, where again people seeing the rise of the internet and the censorship resistant nature were predicting that governments will go against it. It's difficult if not impossible. I think what is happening in this case is that governments will try to co-opt these technologies rather than ban them. And this is what's probably happening now with central bank digital currencies and other forms of incorporating blockchain and centralized architectures into the existing financial system. If some governments, and it has happened in the past in countries like Russia or China or Korea or some countries in Latin America or Africa or the Middle East that went after digital currencies and tried to outlaw them. In most cases, this created such a backlash that it was reversed. When innovation is happening, when you cannot ban innovation because it will simply move elsewhere. So if the US government tried to do that, the thing that it would achieve in the end would be that, innovation would go to Europe or in China or wherever, and the US does not want to do that, so they will try to strike a balance between, having innovation and growth happening in their jurisdiction and not letting things go out of hand and totally uncontrolled. Okay, and I think this finishes the part where we're discussing these subjects. Let me, since I see there's a question by Mohammed that's saying, for those who are registered in the MSc, is the exam an essay and any idea of the subject type? So let me say a few things about the MSc and and how we're moving forward with that. Let me go to this now, which is a preview of the new MSc in blockchain and digital currency, and then I'll finish with the exam. First of all, let me clarify that we're not talking about a new master's program. What we are doing at the University of Nicosia is that we are revising the existing curriculum to address new developments that have happened. We've started the MSc in 2014. I don't need to say much to convince you that the blockchain and digital currencies world from 2014 to 2020 is a totally different world. So instead of simply updating the material within the existing courses, we took this opportunity after 5 years of running the MSc to update the curriculum. So at this stage, the program has been submitted to the Cypriot body for accreditation. And once we receive this accreditation, and we expect it to be in January to March, so the first quarter of 2021, the new MSc program that has a revised title is now called Master of Science in Blockchain and Digital Currency, will replace the existing curriculum. So every MSc student that is already in the program will be automatically transferred to the new MSc. There's not going to be a period where we're going to have some people doing the old MSc and some people the new MSc. Those that have graduated with the old MSc, they did the old MSc. Those that are going to be graduating from now on, from the point that we receive the accreditation onwards, will be graduating from the new MSc. The basic structure is the same. So again, 3 semesters that could be done in 1 calendar year or 18 months. 9 courses, of which 6 required and 3 electives. And this is the program. So we have required courses that are going to be taking place in the first 2 semesters. So semester 1, Introduction to Blockchain and Digital Currency. This is the MOOC. This is the course that we're doing now. Blockchain Systems and Architectures, a more technology-oriented course on the basic elements of blockchain systems and digital currency architectures, and a course on law and regulation in blockchain, where we're going to be discussing the legal taxation and regulatory and policy implications of these technologies. Then second semester, 3 other courses. One called Emerging Topics in Blockchain and Digital Currency. This is a course that we always put the latest stuff in. So if you did it this year, you would hear about stable coins and decentralized finance and liquidity pools and stuff like that. If you do it 2 years down the line, who knows what's going to be topical next. Blockchain and entrepreneurship management, so a business course related to new entrepreneurial ideas related to these technologies, stuff like the ones we have just been discussing based on your questions. And principles of money, banking and finance. This is a finance course that explains how the current financial system operates and how technologies like blockchain, tokenization and crypto assets are changing it. These are the 6 courses that everyone is doing. These are the required courses. And then on the 3rd semester, students will have an option. They will either do a master's thesis or they will take 3 courses, whichever they would like, out of the collection that you see here. So we have a course. The first 4 courses are more technical in nature for those of you that have a programming background or want to go into programming. So digital currency programming is about, the Bitcoin script language and in general programming into directly into monetary and payment tokens. 522 is the smart contract programming, so it's more about solidity and programming into self-executable code that runs on decentralized architectures. And 523 is permissioned blockchain programming, where we're going to be looking at things like Hyperledger or Ripple and R3, so things that have to do with enterprise blockchains. And the 524 is the cryptographic system security, which is the more cryptography and security oriented course for those that are interested in the underlying technology elements of how decentralized systems are being built. And then for those that would prefer less technical courses, we have emerging topics in law and regulation, where we're going to be looking at specific use cases of regulatory approaches around the world. Emerging topics in fintech, where we're going to take a step back. We're going to focus on the financial applications, but not only having only blockchain as the underlying technology, but everything that has to do with the world of finance and how it's being disrupted by technology. And then open and decentralized financial systems, token economics, that's a very important course, and the master's thesis. So that's a map of how the program is expected to run. We have made maps of courses between the old MSc and the new MSc, but I'm not going to go into detail. But depending on what you have done, you will be able to transfer your courses. And we have 2 suggested pathways. As I said, those that want to follow software engineering pathway will do all the required courses, and they will choose 3 out of the first 4 of the electives. Those that want to do the business, finance, and regulation pathway will do the required courses plus 3 of the non-technical courses. Or you can mix and choose, so you're free to do any 3 courses and not follow any of the pathways. And that's about it. And I think this concludes the course. Nishad is asking if the master's thesis can be on any topic. Yes, as long as it is related to DLT, blockchain, digital currencies, tokens, everything that is part of the MSc. You are free to choose your own topic or negotiate with your supervisor what the topic of your thesis will be. Those of you that are interested in the MSc, that are not already enrolled in the MSc, I'm going to just put on the chat now the name and email of our enrollment manager. This is Miss Hazal Aripinar, and her email is aripinar.h@unic.ac.cy. Oops. So feel free to send an email to Hazal regarding the MSc, and we will be obviously more than thrilled to see you there. Now, finally, for those that are doing the MSc now or are simply doing the MOOC course, as you know, the exam is going to take place on the 4th, 5th, and 6th of December, so the end of next week. So you have some time to prepare for the exam. Those of you that are doing only the MOOC, the exam is going to be a set of 50 multiple choice questions, and those of you that score 60% and above on this exam, you're going to receive a certificate of accomplishment that will be blockchain verifiable. The MSc students are welcome to do the quiz as well if they want, but it will not count toward your MSc grade. It will just be for information purposes, and you will also receive the MOOC certificate if you pass the quiz. But in the same time period, you will do a different essay-based exam that will cover the subjects that we have discussed in these 12 weeks. So your main, let's say, reading material will be everything that has been uploaded on Moodle during this time. We will be posting more information about the logistics of the MSc exam on Moodle in the coming days in the section that is devoted to the MSc students. And I wish everyone good luck and all the best, both for the MOOC quiz and the MSc exam. And last thing, thank you very much for your interest in the concept of real estate tokenization. As you might have seen in Moodle, I've taken the decision to organize an optional Zoom call next Thursday. So those of you that are interested, please check Moodle. You will find the details there. It's same day, Thursday, and same time as this session, but we're not going to be doing a live streaming on YouTube. It's going to be just a closed Zoom call. So with this, I would like to thank you very much for being here throughout this 12 weeks. I hope you've enjoyed the course. I would like to acknowledge the help and thank my co-instructors, Andreas Antonopoulos and Antonis Polemitis, and also Dimitris Cheas, who has handled all the logistics of the running of the course, both in Moodle and for the live session. Thank you very much. I'm looking forward to seeing you on our Masters in Digital Currency or in one of our future programs. Thank you very much. Take care. Feel free to send me an email if you want anything. I'll be more than happy to respond to you either to a direct email or on the Moodle. Thank you very much. Bye-bye, everyone.